Hey everyone, today we are going to build a complete production ready AI system from scratch using Azure OpenAI and DSPy. We'll start with the basics of DSPy, integrate MLflow for experiment tracking, and use advanced GEPA optimization to make our prompts better automatically. In this tutorial, we are going to build a product description generator from scratch. We'll take an example of Flipkart first. I'll launch the Flipkart and go to the Flipkart site. Yeah, we'll go TV and appliances. TV and appliance, we'll go with either any TV. So I'm not giving any brand or promotion of Flipkart or any other thing. This is everything for tutorial only. So we'll take this example, like, so if you see the Flipkart, everything got bullet points. Now we are going to convert them to a excellent description of this product. To do so, I'll tell everything from scratch, even the installation part. So please do follow me. Yes, first of all, make sure you have Python 3.11 or above and Git. Now, we are going to do a basic setup. That is, we are going to install the Python environment, I mean the virtual environment, and activate it first. Then I'll show you what we can do. To do so, open terminal, new terminal, and type Python space. So this is a new project which I created. Name is e-commerce product description generator. Python space hyphen m v n v v n v and enter. This will create a VNV folder here. It's a virtual environment to save all our dependencies. We going next step is we're going to install all our pip install dependencies. So all our dependencies will be saved under virtual environment. It will take some time. Yep, this is done now. So I'm going to do okay git bash here so that it will work fine. Now next comment is to we need to activate it, right? So that is we need to do so. If you expand this VNV, you can see the scripts, and inside scripts you can see the activate it. So we going to enable this. So for that, so Mac it's a different command, and for Windows it's a different command. You can get it from online. So here we are going to do so you are so your source space, sorry, so you space vnv v slash sc or ipts slash activate. That's it. Now we are in virtual environment. So if you, to identify, this is the identifiers showing that we are in the virtual environment, and whatever we do pip install, all our dependencies will be installed under this virtual environment. Next step, we are going to install all the required dependencies. To do so, we are going to create a requirements.txt file, text file. Inside this, we are going to add our dependencies. So I have the following dependencies ready. Let me copy and paste it here. And these are all the dependencies required. Uh, I'll so to run this, we need should be txt. Now this will install all the required dependencies under VNV folder. Notice we don't need a separate OpenAI package. DSPy handles Azure OpenAI natively. This will take few minutes to get installed. Next step, we are going to create a .env file to store all our Azure APIs. To do so, let me create .env file. and I have stored all the APIs and the names. I'm going to copy from here and paste it here in the env. So for this env, you should use your API keys for your project. And yes, I'll be sharing all our files and codes in the repository. I'll share the link in the description as well. Once after adding the environment file, .env file, we need to add this in a git ignore. To do so, I'll clear the log first and add the following files to git ignore and never commit environment file to the git. Done. Now I'll create a new file called basic underscore DSPy to give you a basic understanding of DSPy. So DSPy is a framework for programming with foundation models. Instead of writing prompt strings, you define structured signatures. Think of signature as type hints for your LLM calls. Traditional prompting looks like this: prompt equal to, and then you give your prompt with some features, and then you call the OpenAI to give the response, right? So now in DSPy, it looks different. With DSPy, we define signature input and output explicitly. DSPy look like this. Will give a input and output. This gives you composability, optimization, and type safety. Let me show you how. So let's write our first DSPy program with Azure OpenAI. I'll go slow and explain every line. I have my program ready. It's a basic DSPy program. So I just save this file. I'm just loading the environment and configuring the DSPy with Azure OpenAI. In traditional model, what we will do is, the main difference from the standard OpenAI is model format. If you see, the model format says Azure slash deployment name, not GPT-4o mini, and it's like we are just passing the variables like key, base, versions, and all. And DSPy.configure lm equal to lm. This means we are setting the global default model. Now, any DSP module will use this model unless you override it. Let's test this works. To do so, I'll clear the log and I'll type run the file python space basic underscore DSPy dot py. Now, this will print DSPy configured with Azure OpenAI with the model name. Perfect. Let's define our signature in next. Okay, now we'll define our signature next. Like, this is our signature class. So signature is like a contract. It says doc string. What this task does: generates compelling numbers product description from feature, right? And then the input field, what data comes in, like product feature as bullet points, and output field, what data goes out, engaging marketing description, 2 to 3 sentences. That's it, right? Now we need to add one more thing called predictor module. That is basic predictor module. Here, DSPy module. Yes, right. Now, this looks like a PyTorch, right? That's intentional. DSP modules have init, initialize predictors, forward, forward to execute the logic, and DSPy.predict is the simplest predictor It just calls the LLM with your signature. We'll see fancier ones like chain of thought later. Let's test it. So to test it, we need to add this one. So here I'm adding if name equal to main product. Yeah, this is the product description generator class which we created, correct? And we are passing the feature as a bullet points as we saw in the Flipkart, right? These are all the similar kind of bullet points, and generating just a print statement. And we're going to save this file first before executing. We're going to run this one. Python space basic underscore DSPy dot py. Run it. This will run in few seconds. Based on this bullet points, generate perfect. You see, we haven't write a single line of prompt. So we saw the output. Like notice we didn't write a single prompt string. DSP build the prompt from our signature automatically. This is the foundation. Now let's add chain of thought reasoning. Now we are going to do a chain of thought reasoning. To do so, we are going to change only a one line. Not going to change lines, it's just a word. It says DSPy.predict, right? Instead of that, we need to do a chain of thought, right? Click save button, and we are ready to run the same script with chain of thought. This chain of thought makes a model think step by step before answering, often produces a better results. Let's run it. Basic, yep. Yes. If you see, uh, in predictor it says experience unparalleled audio with our wireless Bluetooth headphones, right? But in chain of thought reasoning, it produces experience your music like never before with our wireless Bluetooth headphones. Boating an exceptional, so it's totally different, right? So it generates an excellent description with our chain of thought reasoning, and hope you saw the difference between the predictor versus the chain of thought reasoning. Uh, this output might be coherent. Okay, we have covered DSPy basics, signature defined schemas, modules wrap predictors, predict versus chain of thought, Azure OpenAI configuration. Next, tracking experiments with MLflow. Introduction to MLflow. MLflow is an experiment tracking platform. It helps you to log hyperparameters, metrics, artifacts, compare runs side by side, version models, track prompts, new in 2.9 plus. Think of it as a Git for ML experiments. Let's set it up. To start MLflow, to start our MLflow, we need to add this command and run. It should run in localhost port 5001. It is going to up in few minutes, not few minutes, few seconds. Usually it will take around 60 seconds max. Yep, it's running now. Yep, we can't running at localhost 5001, and it says application start complete. Now we can click on this and open our MLflow UI. Here is our MLflow UI. Right now it's empty. No experiments, no run. We'll change that soon. Notice the tabs: experiments, all your tracking runs, models. to registered models for production. Prompts, version controlled prompts will use this heavily. Keep this tab open. Let's log our first experiment. Okay, let's create a DSPy example with MLflow. To do that, we are going to create a new file called DSPy MLflow.py. Now, I have the code ready. Simple. I just copied from the basic and paste it in DSPy MLflow.py. We have two new lines. If you see MLflow.set tracking URI and MLflow.set experiment. Tracking URI is like passing the server. You're passing the server that last time we, in the last run, we upped the server in localhost 5001, right? That is the server which your MLflow server which are passing through, and the experiment name is product description tutorial. Think of it like a folder where we keep all our runs. So this will show up in the front end, and remaining things are same. Like we added the signature in our last code, product description, and we are going to integrate those things with MLflow start run. So if you see our previous code, DSPy with MLflow. Yep. So yes, with MLflow.start run, this block creates a new experiment run inside. We log parameters, what settings did we use, log metrics, how did it perform, and log artifacts, save files. Let's run it and see what happens in MLflow. Okay, now let's run our DSPy MLflow script. To do that, we're gonna create a new git bash. We should not run in our MLflow running terminal. We should create a new one and run our MLflow script. Python. This will run in few seconds. Running. So this time I added a different product description with like wireless Bluetooth headphones and something. So these are only 4 bullet points, whereas in our previous product description we have multiple. So it says DSPy plus MLflow configure description generator 661 characters logged to MLflow. You run basic description generation at this location at our MLflow server running. New experiment at this location. Okay, let's see our log in MLflow. Yes, this is our MLflow UI where we can see our product description tutorial comes in. Let me click on this and see. We can close this one. Yeah, and see we have our basic description generator, which the name which we given in our code. Let me click on this first and see what are the parameters getting. It says model GPT-4 mini, predictor, chain of thought, and some logs like created at, by whom, experiment, something, and so the file name and all. So if you go to model metrics, it says 661 length, right? Our character which we saw in our log at 661 length, and we can see system metrics, nothing to show, traces, nothing to show as of now, and artifacts. Let's come to the artifact. It says description.text. Our description got generated in a text file. We can see experience music like never before with our cutting edge wireless Bluetooth headphone. Enjoy all our description details over here. Yes, that's it. So we can see our description in our MLflow UI, but we are missing something important. We are not tracking the prompt itself. That's where prompt registry comes in. Let's skip ahead a bit and see the full integration. The MLflow has built-in DSPy support. Let me show you autolog. It tracks everything automatically. Here we have implemented mlflow.dspy.autolog. We have three parameters: log traces, log compiles, log evals. So log traces captures every LLM call with inputs outputs. Log compiles tracks optimization. We'll use this for GEPA. Log evals record evaluation outcomes. Now MLflow sees inside DSP automatically. Let's test it. And also in test, I have modified few things. That is, we have added new feature, and the run name is autolog demo to understand this run is a different one. And remaining stuffs are same. We haven't touched anything, and some prints and some flows. And let me run the script again. Let me clear it. Let me run it. Yes, DSPy plus MLflow configured. Yep, it generates a description. It logged in here itself, and we will see everything in the UI now. Yes, in the MLflow UI, we have product description tutorial, and click on it, and we can see the traces of which we send the recent request for the smart LED bulb, right? So this is a request, and we got the response and tokens, execution time, so and so. If we click on this trace ID, we can see what input we sent and what output we got. So these are all the bullet points which we sent, and it says the output which we got and the LM call, how it defined like features, description, product feature as bullet points, and features. Click on see more, and see inherent to the structure. Your objective is to generate compelling e-commerce product description from feature. You got this, and so and so, and the final output eliminate your space, and this is the output which we got in the front end. And yes, so this is a gold mine for debugging. If your output is bad, you can exactly see what prompt DSPy generated. This is powerful, but we are still manually running on off dates. Let's add proper evaluation. Yes, to optimize prompts, we need training data. Let's create a small data set of product features and ideal descriptions. I'm making a CSV with 10 examples. I have created 10 diverse products with handwritten ideal description. These descriptions are 2 to 3 sentence, persuasive but accurate, highlight key benefits. In production, you'd have 50 to 100 plus examples from your marketing team, but 10 is enough for demonstrate. Now, let's write an evaluation script with the proper metric. Now we have added our product.csv in our project. You can see our product.csv here. And now we need to create new file called evaluate.py for the evaluation process. So the code is simple, same code, same structure, only key change is the load data set which I've updated. So for data load set, we convert CSV rows into a DSPy.example objects. The dot with input feature called marks with fields or inputs. Then a metric function which we wrote here. Evaluation metrics returns float for DSP compatibility. So what we are doing here is takes an example and prediction, returns 0 to 1 score. Our metrics checks are length should be 150 to 350 characters. Coverage mentions key product terms. Important. The metric must return a plain float for DSPy's evaluator. We'll see a more advanced pattern for GEPA later. 7 train and 3 test, small but enough for demo. Let's run it. To run this, we need to put python space evaluate.py. Going to run. Loaded 10 examples, train 7, test 3. Okay, example 150, 50, 50. So average quality score is 50, right? Great. 0.50 average score. Not bad for zero shot. Now we can track improvements as we optimize. I'm going to skip the detailed UI tour for time, but the key takeaways are experiments page, compare all runs side by side, traces tab, see exact prompts into Azure OpenAI, prompt registry, version controls for prompts like Gate. We'll see prompt registry in action when we run GEPA. Let's jump to the main event. GEPA stands for Gradient Free Prompt Acceleration. It's an optimizer in DSPy that automatically improves prompts through reflection and error analysis. Here's how it works. Start with baseline prompt, run on training set, some examples fail, reflection model GPT 4.1 analyzes the failure, GEPA generates new instruction plus few short examples, repeat for n iterations, return optimized prompts. The cool part, dual model architecture. GPT-4o mini, fast, cheap, used in production. GPT 4.1, smart, expansive, used only during optimization. You pay for GPT 4.1 during optimization, but production uses GPT 4o mini with optimized prompts. Let's implement it. Here I'm going to create a new file called optimizer.py. Now, in this optimizer, we are going to do our optimization script. Before we write optimizer, I need to show you an advanced pattern. GEPA needs both the score and feedback for optimization. We'll create a special class that acts like float but carries feedback. And it will be look like this. This is a clever trick. It's a float, so DSPy evaluator can sum average it, but it has a feedback attribute that GEPA can read. Supports dictionary style access, score feedback. This pattern is crucial for GEPA optimization. Now let's write our improved metric. So our metric function will be look like this. So here it's our updated metric function. This metric returns a float score for DSPy evaluation, includes detailed feedback for GEPA reflection, checks multiple quality dimension, length, coverage, style, and that's it. Now let's build the full GEPA optimizer. Now we are going to build a full complete GEPA optimization pipeline. This is production ready version based on real working code. Let me add the code first in the optimizer.py. Yes, got it. Now, in the optimizer.py, I'm pasting the entire production ready code. Before running this is the complete production ready GEPA implementation. Let me highlight some key parts here. This is dual model setup. We have a GPT-4o mini and GPT 4.1, and scores with feedback class, quality metrics as we discussed previous. We have prompt registration, GEPA configuration, and prompt lineage. Now let's run it. To run this, I'll clear the log first and run python space optimizer dot py. Run it. Yeah. So it started running. While this runs, it takes 10 to 15 minutes. Let me explain what's happening. Iteration 1, GPT-4o mini generates description for training set, some fail, low scores. GPT 4.1 analyzes the failure, why these fail, what instruction would help. GEPA updates prompt with new registration. Iteration 2 to n, repeat with improved prompts, gradually add more instruction and examples. Score improves iteration by iteration, and we'll wait for the completion. After the run completed, you can see, wow, we got 34 percentage improvement, and the baseline average is 0.736, optimized average is 0.986, and improvement 0.250. This is amazing. Now, let's see what GEPA changed in MLflow UI. Yes, since it's a new experiment, we have product description with GEPA optimization name we gave already. We'll click on this and see the traces first. We have it's loading because so many inputs and outputs. And so we are not going to this section, we are going to the prompt section first. So if you see, we can do a comparison of how our GEPA optimized our prompts. Let's take version 3 and 4. Version 3 is a baseline V1, and version 4 is a GEPA optimized prompts using GPT-4 mini plus 4.1 reflection. So version 2. See the comparison, how it changed the prompt. It says task generate compelling e-commerce product description from features, but here it totally changed. You are tasked with generating a succinct, persuasive, and benefit driven e-commerce product description based on a provided list of product features. This is simple, but this is more detailed. And also, if you see input and output fields, here it says input format and output format, task description. This looks simple in the left hand side baseline, but whereas the detailed optimized by GEPA prompts are amazing. And you can see line by line, and also gives a summary, give a feature list, generate 2 to 3 sentence description, 150 to 300 characters, that seamlessly weaves the feature into concise, persuasive narrative, emphasizing unique benefits, relevant use case, and emotional appeal. Always within the specific character limit. See, we haven't typed a single prompt. How GEPA itself optimized the prompt and gives us the output. This is really amazing, guys. You must try the GEPA optimizer for your prompt generation. And yes, so all our prompts are focused on customer benefits, not just feature. Use persuasive language like experience, achieve, enhance. Keep 2 to 3 sentence, 150 to 300 characters. Mention unique selling points. We did not write any of this. GPT 4.1 generated it by analyzing errors. This is power of GEPA with dual model architecture. Now, let's use the optimized model in production. So now, to register our model, we need to follow some steps. So open the product description GEPA and click on the training runs, and you will be seeing multiple runs. Here is a GEPA optimized description run, right? So from here, we can see the model which highlighted in here. Just click on the optimized product model, and if you see on the top right corner, you can see register model. Click on it, and we're going to create a new model, and the model name is product description generator and click register. Model registered successfully. Now you can see this model under models. We close this one. Yeah. See, product description generator version 1 is ready to use. Now let's see how we can use this in production and see the output. Now we are going to run our production app using the model which we generated and registered. To do so, we have to create a one file called production.py. Inside production.py, we'll paste our code and nothing much changes over here. Only the change is load optimized model function. Inside this function, we are calling our model. Our model name is product disk gen. So hope you remember the model which we named it while we register the model. And that's it. So before running, we'll save this file. And to run this, says Python space cdn production.py. Yes, it's loading the model. Download artifacts. Load first time. This will downloading some artifacts from the model, and now it asking for the feature. So I have a feature ready for the demo. It's for. Let me take the feature copy and paste it here. Yeah, it's from the Flipkart. Says features: mechanical keyboard, cherry MX switches, RGB backlighting, USB connection, aluminum frame. After clicking on enter, within a second I got the excellent product description. It says experience ultimate typing precision with our mechanical keyboard featuring cherry MX switches. Its RGB backlighting add a vibrant touch to your step setup, while the during aluminum frame ensures longevity, and so right. Now it's perfect description for the product. We haven't typed any prompts, right? And it's benefit focused language, two sentences, approximately 250 characters, mentions all key features. And yes, this is GEPA optimized prompt in action running on cheap GPT-4 mini. Thanks for watching. Questions in comments. Happy prompt engineering.